right, guys, this is the recording for thermal energy 3.2 and 3.3. Kind of squish these two together. We are getting close to wrapping up our unit, so that unit test will be next week. So it's important to kind of make sure you're understanding these main ideas, and we're kind of trying to squish together all the different ideas we have been learning to kind of make sense of it all. So go ahead and click on the assignment for today. And so we started out with a little warm up, and you can see from the diagram here, we have a bathtub and a teacup. And so the idea is that you're going to find the total kinetic energy and the average kinetic energies of each. So for the total kinetic energy, what you're going to do is you'll add them all together. So you go 3 plus 2 plus 2 and so on. So add all the numbers together for the total for each. Your average kinetic energy is going to be adding them all up and then dividing them by how many there are. So for the bathtub, that's 15. So you'll add them all up and divide it by 15. And then for the teacup, there is 6. So add them all up, divide by 6. Then you need to tell me which one has the higher thermal energy. And I want you to remember what thermal energy is. I don't want to give that away. It's going to be one of these, but which one? The next thing is going to be a model. And in this model, we see that Jack created a model that he believes is in equilibrium. So we have object A and object B. These gray circles represent the molecules, and then these yellow squares represent like the speed, the energy, kind of similar to how we have these up here. It's the same idea. And so looking at this, I'm going to draw on it. I see that this one, oh my goodness, that was, there we go. So this one has 8. I'm going to do my 8 like this. And that one has 8. This one has 3, 3, 2, 2, 3, 3. So I can see that there's a total of 16 over here. And over here, 3 plus 3 plus 2. So it looks like my total is 16 over here. But just because my total kinetic energy is 16 does not mean that my average will be the same. So my average over here would be 8, because it would be 8 plus 8 divided by 2. So that's 8. Then my average over here, 3 plus 3 plus 2, we know is 16, but there's 6 of them. So that's going to be, I think it's like 2.6. So I can see that this has a way lower average than over here. So what I want you to tell me is I want you to tell me why Jack is wrong. Why is this not in equilibrium? And you'll tell me in this box right here. And then down here, I did this demonstration, which I'm not going to show you now because it's already done, but we are going to reenact it in the simulation. And so you had to decide, and you can see from the pictures here what happened. I had 100 milliliters of cold water in each container, but in system X, I had 100 milliliters of hot, and then in system Y, I had 300 milliliters. So there was more water in this one. And so you have some predictions to make down here as far as what you think is going to happen with temperature. And then you actually ended up doing it in the demonstration, or I'm sorry, in the simulation, and I ended up doing it with everybody. And I will actually erase those numbers because I learned that if I put all those in there, then they go in everyone else's document, which was cool. So, oopsie. My computer's freezing and going very slow. Oh my goodness, I don't know what I just did. So the link to the simulation is here, and you're going to see there is instructions to follow. You're going to add 2 medium samples. Sample A is going to simulate the water in the cup, so I'm going to make that go down to 4.5. And then sample B is going to be the hot water in the cup. So sample A is the container water, and then this is the hot water in the cup. And then I'm going to push them together. But before you push them together, you need to record the starting temperature and the starting thermal energy. And so you can see here, there's a spot for the starting temperature. So you'd put 4.5. And then we know our other one is 38.6. And then 15 and 90. I got those numbers all from right here. So 15, 90. And then the one tricky thing is there is a column for system. And that just means the total amount of energy. So 15 plus 90, which is 105. You're then going to push these two together and see what happens. Now I'm going to speed it up for time's sake. And you can see the energy is transferring from the hotter sample to the colder sample, and they're kind of equaling out. So eventually, they will be the same thermal energy and same temperature. So you can see now they're both 52.5 with the thermal energy and 21.6 in your temperature. So you're going to continue to do that. And then you will fill in this chart, and then you will do it again, but this time you're simulating the larger sample of water. So this time you'll have a medium sample and a large sample, and you'll repeat the same process. Okay. And then down here, there's a couple questions based off what you found out. And that's that. So make sure you turn it in when you're done.